Hi, I'm David Vogel, and I'm honored to be invited back to Robinhood to speak. Thanks again for re-inviting me, and I'm excited to share some new data that we've come up with over the past year on climate change and in related investment strategies. First, the disclaimer, which I have to do real quick, that past performance is not indicative of future results, and we're not making investment recommendations here. So I usually always start these with basic climate science. Earth and the moon, 92 million miles from the sun, and a difference in temperature of 62 degrees. And what makes that difference, keeps us warmer than the moon, is the naturally occurring 2 trillion tons of carbon dioxide in our atmosphere. So that right amount of carbon dioxide is a healthy amount. We need that to survive. And that was figured out about 200 years ago. So the thought that climate science is a new sort of unprecise science is actually false. We've known this quite firmly for 200 years, and even after the Industrial Revolution, we had projections of what doubling the carbon dioxide in our atmosphere could do to our Earth's temperature. And those projections are not far off from current projections today. And I'm going to show you how we, as humans, have added 1 trillion tons of carbon dioxide to the atmosphere, and how that's going to lead to 6 degrees of warming. So it's not that far-fetched to think that if 2 trillion tons makes a 62 degrees difference from the moon, then another trillion tons would warm us by 6 degrees Fahrenheit. So now let's look at an accounting of the carbon dioxide being added. What you see here is the natural seasonal pattern of carbon dioxide throughout the year. It goes up and down. But what's not natural and not repeating is the fact that every single year that carbon dioxide level, that measurement, increases by between 3 and 4 parts per million. So is this man-made or is this natural? It's pretty easy to prove that humans are responsible because the coal numbers are widely published. Now, these are not numbers from environmentalists. These are energy, well-known consumption numbers. And you multiply out the billions of tons we go through, and you can account for 2 parts per million per year from coal consumption. Now let's look at the oil industry. Again, we all get these oil consumption numbers on our Bloomberg terminals, so it's widely accepted information. Again, not environmentalists making up numbers. And you do the math, and you come up with 1.5 parts per million. So you see, it's quite easy to prove that this increase is 100% man-made when you can account for every single molecule of carbon dioxide increase over the past 100 years. And since 1900, over the last 120 years, we've added roughly 1 trillion tons. And again, just weigh the numbers, take the weight of the consumption numbers, and you can verify what I'm saying. We've added 1 trillion tons of carbon dioxide, all human-made. So now let's look at the relationship between carbon dioxide level and the Earth's temperature. You can see here we have 800,000 years of data. And how do we have that data? It's actually pretty well established science to drill into the ice cores of, say, Antarctica or various glaciers and get an ice sample. That ice sample can be dated using carbon dated techniques, so you know what time it's from. The carbon dioxide can simply be measured, and the average temperature of the region can be known from the density of the water. So that's also another well-known scientific fact, that the density of water varies just slightly, but measurable based on the average temperature of the region. And you get this incredibly tight correlation. Now, this graph on the right, it's the same data points on the left, just lined up differently. If you put on the x-axis all the carbon dioxide levels of all the measurements, and on the y-axis, the delta of the Earth's temperature, at that time, you get a 91% correlation. So yes, carbon dioxide doesn't explain 100% of the Earth's temperature, but it's pretty darn close. It's by far the biggest factor in warming the planet. And based on this, we're currently at that data point on the right, unprecedented in 800,000 years at this level of carbon dioxide. And you can see how we can project quite easily about 6 degrees Fahrenheit of warming as a result of carbon dioxide in the atmosphere. So now the question, how fast is this warming occurring? And how much of those 6 degrees have we realized already? And the answer is we've realized about 2 degrees so far. If you look at the graph on the left, the blue dots represent the actual Earth's average temperature by year, and you'd see it climbing steadily. And the gray line is our model using the laws of thermodynamics, so nothing too complex to project the speed of warming based on the carbon dioxide that we have pumped into the atmosphere using fossil fuels. And you can see that it matches up pretty darn good, and we have only 15 years to the next 1 degree of warming. So we've already warmed the planet by 2 degrees. We measure that, we know that, and we've got 15 years to the next degree. So it's certainly accelerating as long as we continue to pump carbon dioxide into the atmosphere. And I'm going to get to the science of the hurricanes later, but the graph on the right shows that if you're against paying a carbon tax, well, too bad, you're already paying it, because the bill to the U.S. government doubles every single decade, and it's continuing on that trend. So we're definitely paying the price of the fossil fuel combustion. So now I'll get into hurricanes. We actually analyze ourselves 215 million data points from NOAA and every hurricane recorded to figure out the connection. So really, we always know it's well-established physics that connects warm water, that warm water fuels hurricanes, but we wanted to really quantify that into something people can understand. So we looked at hurricanes that had gone through maximum 80-degree water. And all through the whole hurricane database, the strongest hurricane ever was a Category 1. So with 80-degree water and below, you're never going to have a hurricane more than a Category 1. Now we looked at 81-degree water, and we got Hurricane Diana. It was 115 miles per hour. 82-degree water, the strongest storm was Hurricane Gert. Still, keep in mind that 82 and under degrees is still, at least historically, has been impossible to achieve a Category 5 storm. Hurricane Lorenzo, in 83-degree water, and for 84 and up, we had a tie for the strongest storms. Gilbert and Dorian both went through 84, 85-degree water to achieve their wind speeds of 160 miles per hour. Additional notable storms that didn't quite make the chart because they weren't the max were Andrew and Katrina. They also went through 85-degree water, were Category 5s. They were just a few miles per hour shy of Dorian and Gilbert. And Hurricane Harvey went through 86-degree water, didn't quite achieve the same max wind speeds, but was historic in the amount of damage it did. So certainly a very powerful storm. So you can see, in effect, by heating the atmosphere, that the slope of this line is 15 miles per hour per degree Fahrenheit of warming. So by heating our atmosphere by 2 degrees, we have actually increased these storms by 30 miles per hour. In another 15 years, we'll have another degree, and that's 45 miles per hour. So these are man-made, or at least man-accelerated storms from our own work. And we continue to be in denial about see, the science is so clear. We're still in denial over man-made or humans' contribution to climate change, and we need to get rid of fossil fuels. That even when asked in recent debate if climate change was man-made, our own vice president said that we'll let the science decide that. Well, I'm here to tell you the science has decided that, the science decided that 200 years ago, and the science isn't going to change its mind that fossil fuel combustion warms our planet. So this slide here shows where the costs fall. And in the 80s and 90s, you look at sort of the gray bars, those are the percentage of climate-related damages covered by insurance. It used to be about 50%. Insurance companies are knowledgeable of climate change. They're pulling out of a lot of coverage, and the cost has fallen upon the taxpayer. The taxpayer are the blue bars. The taxpayer used to cover 15% of climate damages. Now we cover 45%. So we're paying a higher percentage of a much larger number, and it's really biting into our finances. And the graph on the right, you might think, well, hurricanes, how can hurricanes be the biggest part of this expense? It only affects one part of the US. That little section of the US that's vulnerable to hurricanes actually represents over a third of the US population. I wanted to show a quick slide on Florida, because Florida is probably the most vulnerable state economically from all climate change, from changes in temperature. So certainly we are very likely to get hit by hurricanes, but also through all these bullets mentioned here, we're looking at increased water contamination, pollution where we swim, extreme heat days, and certainly healthcare issues. Not to mention our #1 industry is tourism, and tourism could be affected substantially, especially if people can't swim in the beaches, or if it's so extremely hot that people don't want to visit. So Florida, of any state, should be quickest to jump on decarbonizing quickly, so we don't warm our temperatures even further. So now I'm going to get to how do you organize a portfolio based on knowledge of all this climate change. And the way we like to think of it as 3 main areas. Mitigation and adaptation sort of balance each other out. We think of mitigation as sort of phasing out oil. So the investment correlated with that would be sort of shorting oil stocks. And certainly that's done well, even without trying hard enough to decarbonize. As you see, XLE, the ETF, has averaged about minus 12% a year over the last 5 years, whereas the S&P is up 12%. So huge underperformance of oil and gas. But you also have to also consider the adaptation, because there's a chance that we'll remain in denial. We want our investments to be policy independent. And if we don't mitigate, we have to adapt. So you need to think carefully about what companies will emerge and thrive as a result of the adaptation needed from increased storms, increased needs for healthcare. Transition we put in its own category, because we believe that the clean energy transition is inevitable regardless of policy, just because clean energy is becoming cheaper and electric vehicles are becoming more economical. So in terms of electricity being cheaper coming from wind and solar, that's actually fairly new. The key line to look at on this graph is the orange line. That represents the ratio of the cost of natural gas over wind and solar. And so that line, the blue line, that blue straight line at 100% is the crossover when wind and solar became actually cheaper than natural gas. And that happened roughly about a year ago, maybe a little over a year ago. Before that, wind and solar were getting competitive, but not quite there. Well, as I mentioned in my talk a year ago, we have just got there, that the cost of renewables is actually cheaper. So from a pure economic standpoint, even disregarding policy and global warming, it's better to bet on wind and solar stocks than say natural gas stocks. The adaptation, that is probably where the most innovation is needed for a portfolio. So I'm just going to give a sample, but sort of discretion early. In our opinion, we thought of winners in the winners in adaptation. For example, Home Depot, largest construction retailer. There's going to be a lot more rebuilding and there's more damages. We looked at sort of the infrastructure that next door is getting all this infrastructure money from the government, generators. So this is where a lot of creativity comes into play. So just think of this as one sample of probably 1,000 different ways you can have a portfolio for adaptation. In this particular case, it has outperformed the market by 4%, but it's also really more important than the back test is that we expect future outperformance to be even more due to inevitable changes in the climate. Electric vehicles, another category. In this case, you can split electric vehicles into leaders and laggards. The outperformance is extraordinary, 18%. EV leaders are not necessarily just car companies, but also battery companies, power management, anything related to that field. And you see the outperformance accelerating. And if you actually break down the cost between EV and gas-powered car, the EV may have a bigger sticker price, but if you consider the rebate, the tax rebate, that many thousands of dollars you save on maintenance and repairs, the many thousands of dollars you save on fuel, and the fact that the resale value is higher, it is actually way more economical at this point to buy EVs. And that's why our belief is based on the data that EVs are going to overtake gas-powered cars. And that's why we see this huge difference in performance. I think it's important to also understand that we can quantify, if we can quantify the amount of damages done by carbon, we can come out with $1 per ton and how that is impactful to the economy. Now, whether or not it's $200 a ton or $150, we know it's high, and we know it's in that order of magnitude. But it's important to consider that when you buy a gallon of gas, you might spend $3 for that gallon of gas, but there's another $2 of damage being done somewhere in the world that is currently not being taxed. Same with electricity. For every kilowatt hour you use, if that is sourced from natural gas, there's 12 cents of damage being done somewhere in the world. And if you can quantify in that way, that can lead to effective policy to penalize carbon, because it sort of makes no sense to allow polluters to pollute for free so that they maybe save, let's say they save $5 billion because of being deregulated, but it costs $50 billion worth of damage, then that makes no economic sense, just not efficient. But until we have, and being part of the CFTC committee recently on climate risk, it was a pretty bipartisan, it was a bipartisan decision that, or recommendation that we need to put a price on carbon, and most, when you poll people, about 75% to 80% of the population believe taxing the polluters is the way to do it. But until then, you can do reforestation for the price of $20 per ton, but nobody wants to donate that much money to reforest everything. For almost that price, you can actually you get almost the same impact in investing in a solar farm. For every $30 you invest in solar farm, a ton of carbon gets offset, and you get an 11% return. Extremely competitive. When I gave this talk last year, it was 10% return, and as the price goes down for solar, the return keeps going up. So it's becoming more and more competitive return. It's a great investment to do something good and get a competitive return. I wanted to throw in there some information on the healthcare, because certainly there's going to be a lot more healthcare demand due to changes in regulation. We have a coal-funded politician, or we had a coal-funded politician in charge of the EPA, determined to roll back and make it easier for coal companies. He was thrown out after 2 years because of embezzlement charges. So we threw in another coal guy to run, and this is this is to run the Environmental Protection Agency. So we're rolling back, we've actually rolled back measures that now allow coal companies to dump coal ash into the water supply, which is known to cause cancer and other nasty conditions. And we also have a chemical lobbyist in charge of the EPA's chemical safety. So just some thoughts on think about your healthcare investments as demand increases. So speaking of coal, my donut stocks last year, the stocks that I predicted go to zero were 3 coal companies. And you look at all the nasty things that coal does, and that was sort of the reason. It's not only not economical, but so many people die from medical conditions associated with coal. Now coal ash going in our water, polluting our water supply. So for those reasons, at this point last year, as coal was already down substantially, I predicted these 3 stocks to go to zero. And even with the US government behind coal, they still could not turn a profit. And you can see all 3 of those stocks are down more than 50%. Peabody Energy specifically almost made it to zero, but not quite. It had earnings of negative $1.5 billion last quarter, and they got class action lawsuits from investors for investor fraud piling up. So I'm keeping my short positions, and I still think they're going to zero. And I'm going to stick to those picks. Give me 1 more year for those stocks to get to zero. Thank you very much. And next, I'd like to welcome my friend Jules Kortenhorst, CEO of Rocky Mountain Institute, who knows much more than I do about the clean energy transition, and I'm really looking forward to asking some questions. First of all, Jules, thanks so much for spending time to come on and answer some questions.
Happy to do so, David. It was a fascinating presentation that you just gave.
Thank you. Thank you. I'm very curious if you could give some recent examples of clean energy companies that are starting to outperform more traditional energy companies in the stock market.
Thank you. Yeah, that's a good question. It is quite stark to see the contrast between those industries that are struggling and those companies that are doing incredibly well. Recently, I was in a meeting with the senior leadership of a very large international oil and gas company, and they were looking for breakout opportunities to move their business towards the new energy future. And in preparing for that meeting, I had looked at a company called Ørsted to see if that would potentially be a acquisition target for this very large international oil and gas company. Ørsted used to be known as DONG, and DONG stood for Danish Oil and Natural Gas, and it was essentially the operator of coal-fired power plants in Denmark and of oil and gas exploration and production on the Danish continental shelf. This company, over the course of the last 6-7 years, has completely transformed itself. It's gotten out of the oil and gas business, divested that. It has converted much of its coal-fired power operation, which had partly shut down, but what wasn't shut down, converted it to biomass. But the core of its business has become offshore wind development. And what was essentially a non-existing industry 10 years ago is now a global industry, growing incredibly rapidly and outcompeting traditional fossil fuel power generation in many parts of the world, China, Europe. And Ørsted is clearly the dominant leader in this industry. Their market cap was $60 billion a couple of weeks ago when I looked at it. And that stacked up to order of magnitude $100 billion for the international oil and gas company that I was talking to. It is quite striking. It is quite striking that this global behemoth of oil and gas is no longer in a position to acquire a relatively modest renewables developer. And it is a clear indication that the market has started to value the growth of renewable energy quite significantly. Another example that we're of course all familiar with is Tesla. And Tesla in some ways is a very unique story, just like Elon Musk is a very unique individual. And I am not a stock picker, David. I don't do your job. You probably would be better at my job than the other way around. But it strikes me that the market is sending a signal here that they recognize those benefits that you talked about in terms of owning an electric vehicle over an internal combustion engine car. But also, Musk has been very clear that he believes that the continued cost reductions in batteries are not going to slow down, and that as a result, the competitiveness of his vehicles compared to internal combustion engine cars will continue to improve. We, in fact, think that it is somewhere between 2023 and 2025 that we'll see for many models the crossover where electric vehicles will become cheaper upfront than internal combustion engine cars. And that is, of course, a real breakout moment for that industry. So just two examples of companies that I think are doing extremely well and are illustrating how they are outcompeting the traditional OEMs and the traditional energy sector.
Wow, that's incredible. I guess that brings me to the question. So fund managers like myself and others have been doing well shorting oil and gas companies because of the inevitability to be phased out. But is it possible for an oil and gas company to pivot, or at least one of the big companies pivot and gradually migrate to a portfolio of clean energy so they not only survive but even thrive?
I think the answer to that question is still unclear. There are arguments that would lead you to believe that they should be able to do so, and then there are unfortunately also arguments that suggest that that's really hard. Let me start with the arguments why it's hard. Oil and gas companies have historically been molecule companies, and they're trying to become electron companies. But the molecules business, the physical goods business, is a very different business than the electrons business. And so that transition is a really tricky one. The second thing is that the oil and gas industry has historically been one of very large projects, big investments, long investment cycles, high risks. And the new industry is one of much shorter investment cycles, smaller projects, different risk profiles. And are these companies really capable of shifting their operating mindset to deal with that very different profile of investments? And the final question, and probably the biggest one, is one of competencies, culture, and speed of execution. And if you think of the history of this industry, it maybe has been companies that were quite confident in their own capabilities. Now there's a need for them to be humble about the new skills they have to learn, the new culture they have to create, and the speed at which they have to operate in that new arena. So those all would lead you to think these are very difficult transitions. The flip side is that many of their customers have relied historically on the oil and gas industry to provide them with energy, and in some ways have created trusted supplier relationships. So can they leverage that? And the second thing is they have massive balance sheets that they can leverage in making this shift. But then you get into the question of valuations and free cash flow. And obviously, over the last 9 months, the industry has seen a massive decline in their cash flows and huge pressures on their balance sheet. So can the industry adjust? Some players are definitely trying, and we would like them to succeed. Others are much more hesitant. But it wouldn't be nice to be the CEO of, let's say, Exxon and say, we'll carry on with this for another 10, 15 years and may the last one turn out the lights.
Interesting. So I'm curious, what fundamental trends and costs of clean energy are driving investment shifts?
So we see several major trends that are making clean energy, but more importantly, all of the sort of sustainable solutions more attractive. I can't go through each and every one in detail, but let me take a few major points. First of all, we see technology becoming more and more capable. The technology solutions are getting better. My little Tesla is simply a better car than the BMWs that I used to drive. Secondly, the cost drivers that we've already discussed and you illustrated so clearly in your graph, the crossover of wind and solar versus gas power generation. So many of these technologies have unbelievable learning rates. In the case of solar, it's upwards of 25%. In the case of wind, it's 15%. In the case of batteries, it's around 22%. Those learning rates make these technologies more and more cost effective year on year on year. And that is an unrelenting pressure on the traditional industries. Then the pressure of policy and the readiness of politicians increasingly around the world to address climate change is, of course, wind in the sails of the new energy companies. And the last point I will make is that people often think of this as a development or as things that are happening in the developed world, in Europe, in Japan, in the United States. But let's not underestimate the speed with which these technologies are now also scaling in emerging markets and developing economies. In fact, 2 years ago, it was true that China had deployed more wind than all of the rest of the world combined. And India has become a real leader in the rollout and scale up of utility scale solar. We see the same happening now in the Middle East and in Africa. So this is no longer something that happens in wealthy countries' niche markets, but it is a global trend. And that is, of course, adding to the momentum of the industry.
That's very neat. I agree that the electric car is a superior product. I've been driving one for 4 years myself. And before that, I remember constantly being in the shop for maintenance or this or that or a belt change. And you got thousands of parts in a combustion engine versus 18 parts in electric. And all I've been in the shop for is a few tire changes
Exactly.
for the Tesla. So like you said, superior car both in enjoying it, but but also cost. And it will be neat to see when the sticker price comes back down. So curious, how is the energy transition starting to play out amongst global markets?
Yes, it is quite interesting to see the different pace in different sectors and in different parts of the world. In electricity, it's very clear now. We know where we're heading. We're going to have an electricity system that is going to be dominated by wind and solar. It's going to be backed up by demand response, the ability to modulate demand to match supply, as well as battery storage. That is going to be a very smart electricity system, a digitized electricity system. And in different parts around the world, that market is emerging. Denmark and California are further ahead than, say, Georgia or parts of former Eastern Europe, but it is scaling quickly. And as I just said, it's also scaling in developing countries. In the electric vehicle arena and in mobility, we were just talking about the superior performance and the improved economics. But there's one other major factor that I think will accelerate the shift of this industry. If you're an automotive manufacturer, you know that one of your biggest investments is in getting a new platform ready for production. That is $1 billion bet. You can't make those bets simultaneously for your internal combustion engine cars and for your electric vehicles. You're going to at some point pivot your whole product development and platform development effort from internal combustion engine to EV. We've already seen that happen at companies like Volvo, Volkswagen. I think Daimler is close. We're seeing hints from General Motors in that direction. Over the course of the next couple of years, we'll see bold and big moves from these OEMs shifting their portfolio development completely to EVs. So that sector seems to also be well ahead. Far less clarity on what is often called harder to abate sectors: shipping, aviation, steel, cement, parts of our industrial base and our global mobility and transport system where we don't have the ready solutions in place yet and where more technology development and scale up is still necessary. What are the implications for the traditional fossil fuel market segments? I think coal is dead. You illustrated it very nicely with your graph on the valuation of US coal companies, but around the world, coal will see its demand decline very rapidly now. It will not recover from the crash as a result of the pandemic. But oil, interestingly, is also now closer to that peak. It may actually have been the current year. We may look back and say 2020 was peak oil, not because of supply, as we thought 30 years ago, but because of peak oil demand. Depends a little bit on how quickly we recover from this global pandemic and how behaviors readjust to the old patterns. And then finally, gas. Gas has often been the sort of hope for the oil and gas industry, the sector that could potentially carry them through. But as your graph already illustrated, the hopes that gas would become a big growth area in power generation, that's over. Wind and solar are now consistently around the world the cheaper alternative. So it is, in my mind, very questionable that gas demand will scale in the way that the oil and gas industry has hoped. And that could mean that gas will peak sooner rather than later and decline more rapidly than was originally foreseen.
Those are some great insights, Jules. We only have a few minutes left, but I wanted to ask you something about the wonderful programs you have at Rocky Mountain Institute to promote business growth in the clean energy area. Could you maybe talk a little bit about the third derivative incubator program that
Yes.
we are, of course, proud to potentially be participating in?
Super. Well, thank you for that opportunity. Yeah. So as I mentioned already, we're upbeat and optimistic about the technology readiness in areas like electricity and in electric vehicles. But even there, much innovation is still happening, and it's an exciting arena. But in the harder to abate sectors, in heavy industry, in heavy goods transportation, we are still working on developing the solutions that will help to decarbonize these sectors. And even in something as old and long known as air conditioning, we've just demonstrated with our global cooling prize that you can see dramatic improvements in innovation. So in order to drive that innovation and stimulate the ecosystem of venture capital, corporate venturing, startups, and incubators, we've created Third Derivative, which is a collaborative of the largest network of incubators in the world, Energy Nexus. By now, 7 venture capital partners and more in discussion from around the world that are specifically focused on the energy transition. 12 of the largest companies in the world with big corporate venture activities in this arena that have teamed up with us, and that group is growing as well, and we're still open for more members. And over 600 clean tech startups that applied for our first cohort to join this ecosystem. And we were very pleased to see the quality and diversity of the innovations that those 600 startups represented. It's going to be a very hard task to down select it to the 50 most promising ones. But we're working with these corporate venture capital groups, with these regular VCs, and with Energy Nexus to select the most promising of these startups, to focus the efforts on the insights and the technologies that we need to drive most urgently to accelerate the low carbon transition. And this Third Derivative platform will formally launch in about a month, but work is pretty much complete for the launch. We're very excited. We are still in discussion to fund the special purpose vehicle with which we will provide each of these startups with a safe note to accelerate their deployment. And if anybody is interested in talking to us about it, please come find us.
Great. All right. From what I know about the programs, I think they show incredible promise. I think they'll make extremely positive impact on the world. And so for that, I want to thank you for the work you do at Rocky Mountain Institute, and also thank you for coming on to answer these questions.
David, thank you very much. It's a privilege to speak to all of you, and as always, a joy to work with you. Thank you.